So welcome back to the final session of the school, not of this of the day. I would like to, it's a great pleasure that Mr. Ashish Ruparel from Sonata Software, who was generously sponsored, Sonata sponsors the school. So a hearty welcome to Mr. Ashish Ruparel. So Mr. Ruparel is a business intelligence architect at Sonata. He has been at Sonata for 15 years now. So in his previous position at Sonata, he was a senior tech lead. So his interests are in architecting business intelligence solutions. So and he has been a computer geek since his school days, right? If I'm not wrong. And so the topic of today's talk is building analytic solutions for enterprises on the cloud. So this, we organizers believe, will very nicely complement all the theory what we have seen over the previous lecture. So and Mr. Ashish Ruparel is also going to, so this talk will basically cover how enterprises can use the power of the cloud and data to build end-to-end analytic solutions, possibly touching upon big data and machine learning, IoT. These are all the very important buzzwords of today. So over to Mr. Ashish Ruparel.
Thank you, Vivek, and good evening, everyone. I think you all would be very excited for this particular session of mine. Not because I'm delivering, but this is the last session of this particular 5-day stint over here, and last session of the day, last session of the week. You have come from different parts of India, so you would be exciting. You won't be looking forward to go back home, maybe. So, yeah, this is an exciting session, and I'll try to keep it more excited.
I'm sure the topic is also exciting.
Yeah, so let's see. So, to start with, let me just pull up the first slide. I don't know how many of you have actually seen these kind of bank statements, this kind of receipt books and invoice books. So these were used not long ago, but yeah, almost say three decades ago. This was very popular, and I've seen my father writing books of accounts and such big books, maintaining multiple books of it, because we follow a double entry system where when you make a sales, you have to make an entry in the sales book. You have to go to the ledger. You have to make. I'm not an accounts guy, by the way. I might make mistakes over here, but yeah, you make an entry against the account that okay, this is the amount that you need to receive. And towards the end of the year, then you need to reconcile all the things. So there were a lot of challenges. So there were challenges like you need to do the reconciliation. Your data it's all manual, laborious task. So it is error prone. Wherever there is a human touch, there is a chances of error. So it's error prone. And again, as I said, reconciliation was a big challenge. So then about 2.5 decades back, what we got was a computer. So then people started building softwares on the independent computer, wherein you can, key in your sales order. So it will generate the invoice. It will also automatically write data into the books of account. It will ensure that the entry is made in the sales register, the entry is made in the ledger account, so that you know how much money you need to receive from a particular customer of yours, how much money you need to pay to the suppliers. So the life was becoming easy, but still there were challenges. So those are the different kind of reports that it would automatically generate for you. But still, it was a standalone system. There was email, yeah, so you might get some orders over the email, but still, you were still in your own isolated area. So then came the internet. And now, there is a pictorial representation of a typical life cycle of an e-commerce order. Everybody of us uses e-commerce. We go to Amazon.com, Flipkart, whatnot, any of the online retail websites. And then as a customer, we log into the computer or on the mobile device, we place an order. Then the order gets to then we definitely make a payment. So there's a credit card authorization system, the bank system that authorizes it, ensures that you are the right person who is doing placing the order, making the payment. Then it goes to the fulfillment center where the stock is verified, whether they have the stock for that particular item or not. And then it goes to the transportation department So once the particular item is identified, it is being labeled, it is tagged, it is labeled, and then it gets into the transport system. It is handed over to the freight forwarder. And if the distance is less than 200 miles, I'm just giving an example. It can be different. That variable is subjective. So if the distance is say 200 miles, from that local facilitation center, it will get onto a truck and it will get delivered to the customer. If it is more than that, it will then go to a central hub, it will get loaded to a plane, it will go to a local regional center, and from there it gets onto the truck and it gets delivered. Now, right from the point that you visit a website, you log in, till the parcel is delivered to you, we are all very anxious. I check the status of my package at least 10 times a day. I know it's going to come after 5 days, but still every day I check it. So I'm sure all of you would also be doing that, or many of you, if not all of you. So today, the need of the customers have changed. So back when almost 3 decades back, when I wanted to buy something, I had to go to a physical store, or if it's a merchant establishment, or if it's a business, then someone will place an order over a mail, or they'll call, or some person will visit me, and they'll place an order that, okay, these are the items that I need. And then I would make an entry in my book, and I would send, I'll ship. No one knows when it reaches. It does reach though, and then I get my payment. But today, this is a fast lane survival, right? So everybody is in a fast lane. And because of that, we are generating a lot of data at each of these touch points. And this is just one line of business, a retail. Imagine there's a travel business. There is medicine, distribution, manufacturing. There are so many different businesses, line of businesses that exist today. And each of those generates lots and lots and lots of data. So what do we do? How do we manage? So that's where came the birth of big data. So that's what big data is all about. So with the increasing data volume, increasing complexity of the data, the nature of the data, the type of analysis that we want to do on the data, and the changing economics. Now, earlier, to store 10 MB or to buy a 40 MB hard disk, it used to cost a bomb. And now in a fraction of that amount, you get a 32 GB pen drive, a small pen drive. So that's how the technology has also evolved. So it is empowering each one of us to store more data, do some analysis on top of that. And also, the set of questions that we ask. Now earlier, yeah, we know we have placed an order, it will arrive. But now, as a consumer, we are over anxious. We want to see where my package is, where it is lying today. When will I get the delivery? So, and as an organization, I want to understand what is the sentiment of my customer. How are they feeling about my product? What are they putting on Facebook? What are they putting on the Twitter account? How many people are following them? Because that will have a direct impact on my product, on my organization. So there is a lot of different kind of questions that have arisen now, which is again giving birth to big data. So earlier we had small ERP packages. Now it is small. Earlier it used to be considered to be very big, but we have small ERP packages that used to generate gigabytes of data. After that, we came to Web 2, where there's digital marketing, there are mobile advertisements and all, which is generating terabytes of data. But now, in today's world, in today's connected world, we are generating petabytes of data. So every device has GPS location connectivity, every device has sensors, and we send a lot of data. Now today, from office, every day when I travel back home, I ensure that I send a live location to my wife on WhatsApp so she knows where I am. And she knows when I would be reaching home. And to my advantage, the moment I reach home, I get a hot cup of tea. So that's my advantage, right? So that's how it helps. But yeah, we are generating a lot of data. And to catch on some of the customer or consumer scenarios, so it helps in infrastructure optimization. So we can, based upon the IoT sensors, we know that, okay, when a particular system is going to fail, we can predict that. And we ensure that, okay, we have sufficient backup in place, we can take care of it, we can do preventive maintenance to avoid any shutdowns. Churn analysis. In retail, be it mobile or any retail outlet, customer churn is a big challenge. So that's a big challenge that any retail organization faces. They want to ensure that their customers do not go out to their competitors. So advanced machine learning can be used to detect churn analysis, fraud detection. So when you're making a purchase online, when you enter your credit card number, there is someone who is monitoring it. I have received calls many a times from my credit card company. So if I'm making a purchase above 40 or 50,000 rupees, I immediately get a call that, hey, is this you who have placed this order? Or is your card stolen and someone is using your card on behalf of you? And they confirm, and then my transaction gets processed. Otherwise, that transaction is blocked. That's because of the fraud detection in place, algorithms in place. So these are some of the scenarios. Weather forecasting. Weather forecasting also plays a very important role. So now, when we are looking at the e-commerce fulfillment cycle, so now there are multiple factors, right? So when as a customer, when I'm placing an order, it goes to the fulfillment center, and over there, they need to understand when will it reach the customer. So the weather forecast helps them to determine that, okay, is there going to be a snowfall? Will the roads be blocked? Will my truck get stuck on the road? So depending upon that, they can route the trucks accordingly and ensure that the goods reach the customer on time and in a proper condition. So this is all different scenarios where big data helps. I'll give a quick introduction about Apache Hadoop. So it's an open source flavor of Hadoop, and it has highly scalable file system where the data is spread across multiple nodes. I think you would all be already aware of it. And data volume, variety, velocity are the three major components that defines big data. Then we have Hadoop capabilities. So almost all Hadoop instances are capable of doing an extract of data, extracting data from the source, transforming it, doing some kind of transformation, because not all the data is usable in the Azure's format. We'll have to do some cleaning on top of that. So you can do data cleaning, loading, and then it does the distribution across the nodes, and that helps in doing fast computation on top of your data. And last but not the least, it does help in doing predictive analysis. It has you can write algorithms that can do predictive analysis, machine learning, and graph processing. I don't know if you're aware of graph processing, but that's the kind of data that you find in multi-level marketing organizations, where you have one node and they sponsor a couple of people below them, then each of them further then sponsors their downline, and it forms a complete chain of graph. That's where the graph processing helps. What Hadoop is not. So it's not a replacement of our data warehouse. It can store data, it can process data, but it is not a replacement of data warehouse. So people many times get confused that, okay, can we replace our data warehouse with big data? No, you cannot do that. You cannot replace data warehouse with Hadoop. It's not a replacement to C# also. C# is one of the languages that can be used to write scripts or to write scripts within HD Insight. I'll talk about HD Insight later. But yeah, to write scripts that can do processing for you. So it's not a replacement for C#, and it's not a process for a slow moving data. It has to be fast. It has to be fast. So again, these are some of the use cases of Hadoop. So as I said, in retail, we can do, it also helps in achieving 360-degree view of a customer. I'll try to touch upon that again in the later over here. Yeah, it helps in fraud detection. For utilities, it can help. So if you have IoT devices, you are capturing the pressure of the gas in the pipeline. It can help you in detect any leakage of gas from your pipe. So using that remotely, you can shut down the valves, shut the valves, go to the particular problem area, and you can fix the leak. So that's how it can help all utility agencies. So now, having said that, I would like to map that with the Azure data landscape. So Azure data landscape is nothing but the cloud-based data offering from Microsoft. So Microsoft cloud offering is referred as the Azure offering. So from here on, I will just focus on the Azure offerings from Microsoft and how it can be used to convert the enterprise data into intelligence. So now these are the different options. These all are individual services that are available from Microsoft. So the first one is the services that is used to fetch the data. So using Data Factory, import services, command line utility, and Azure SDK, you can fetch the data from different data sources and get it into the Azure environment. The second is the Azure SQL database and the Cosmos database. So these are the structured data store where you can directly, once you get in your structured data, you can directly store over there for further processing. Then comes the Azure SQL data warehouse. So this is a massively parallel processing data warehouse that can not only store structured data, but it can also store unstructured data or semi-structured data through Polybase. So you can ingest that data directly into Azure SQL data warehouse. Then comes the Azure Storage Blobs and the Azure Data Lake Store. So we'll touch upon the Azure Data Lake Store in subsequent slides. But these are used to store all kind of data that you want. It can be structured data, semi-structured data, or unstructured data. It can be stored in both of these storage types for further processing. Then comes the Azure Data Lake Analytics and Spark. So these two can be used to process your data, get insight from your data at a later stage. So once the data lands into your data lake or your SQL DB or your data warehouse, you can use these to do further analysis on top of that. Then we have the IoT Hub, Event Hub, and the Kafka. So these are used to process the IoT device. The data that is being published by the IoT devices can be ingested, or this is the landing place for that data. So the IoT device has to speak with one of these services, and those services then in turn will push in the data into the Azure stack. So that becomes the landing zone for IoT devices. Then we have Azure Search and Azure Data Catalog. So that helps in searching for the metadata of the data within Azure environment. We have Stream Analytics and Spark that does the further processing of your streaming data. And then we have visualization. So we can do visualization using Power BI, and it is supported by Azure Analysis Services, where it becomes an intermediate layer where you have all your measures and formulas written. Then we have Azure Machine Learning and R server that can be used to do advanced analytics. And last is the bot and cognitive intelligence, bot services. Bot services are also very famous now, where there are bot agents at the other side of the support services, and you can interact with them and get some of your queries answered. And all this is supported by the backbone, which is the of Azure Express Route, which helps you to move data quickly onto the cloud. We have Azure Active Directory that does the authentication, the security groups, key management, and then we have Azure Function and Visual Studio that helps us to write different functions and logic to do the processing. So this is the complete Azure Data Lake landscape, and out of that, the highlighted ones comprise of the big data. So these are the components of big data. Okay. And when it comes to logical grouping, so this is how the logical grouping of these data services can be done. So we have the different data services. It can be the data sources, your apps, sensors, and the information management becomes the first step, where it gets connected. You pull the data, then you store it over here, you do the processing, you can add some additional intelligence to that, and then do the visualization. And these visualizations can be exposed through any of the channels. So we'll go into each of this in detail and have a look at it. So first is the information management. So first step in that is the data factory. So data factory helps us to connect any kind of data source, be it on-premise or on cloud. And then using that connectivity, you can land it, you can do transformation, and you can land it into one of the data sources within Azure. So it helps us to connect to multiple different data sources, orchestrate that, pull that, and store it into Azure. So the second offering is data catalog. So data catalog helps us to maintain a metadata of data. So now, when you're building a data lake, or you're building a huge, for the enterprise, when you're building a huge data warehouse, there will be hundreds of tables, and not everybody would be aware of what each table is used for. So data catalog helps us in describing those and storing that. So as a data scientist or as a developer, when you go and search against data catalog, it can tell you that, okay, for this kind of data, this is where you need to, these are the tables that you need to use. Okay. So then is the Event Hub. So Event Hub is used to connect to multiple data sources that publishes streaming data. So it can be IoT devices, sensor devices. It pulls the data into itself, and then there are multiple ways of accessing that information and storing it for future analysis. So that's the task of Event Hub. So now I'll just take a quick step on the two different approaches that are widely used in building data warehouses for enterprises. So one is the top-down approach, where the strategy of an organization is clearly defined. They know what they want to see, and then you gather the data depending upon that. And this kind of top-down approach is mainly used to do what-if analysis. Not what-if, but what happened analysis, to do a post-mortem. As you know, why did my sales fall? What was the reason behind that? That can be achieved by a top-down approach. For a bottom-up approach, on the other hand, is the approach where you start collecting all the information uphand. You start collecting information about an enterprise, whatever it may be. You keep gathering it, and then the data itself tells you the insight from it. So you get the insight from the data itself, and that is used for predictive and prescriptive analysis. So from that data, you can tell that, okay, what is going to be my sales in 6 months down the line, and how do I change it? That's a prescriptive. So from the data, from your previous data, you may come to a conclusion that, okay, sales or giving a discount on a particular product has also driven, so giving discount on a product A has also driven the sales of product B. So if you want to increase your sales of product B, you know that, okay, if you give a discount on product A, it's going to push the sales of product B as well. So you can change the behavior of the consumer by giving a discount on a particular product. So that's the prescriptive analysis that can be derived. So the traditional data warehouse uses a top-down approach. As I said, you go to you understand the corporate strategy, you go and meet with the business users, you go and meet the technical users, collect the technical requirement, do a database modeling, data warehouse modeling, build the ETL packages, build the reports, and you deliver that. So that's how a top-down approach is addressed. In the bottom-down approach, you start pulling in data from all the different data sources that an enterprise is worried about. So it can be the Twitter handles, social handles, the devices, videos, line of business applications, anything that is concerning to an enterprise. You start pulling the data from those data sources and put it into a data lake. You store it in an as-is format. After it is stored, you start doing analysis on top of that, and that gives you an insight. So typically, data lake is built using a bottom-up approach, where you start pulling all the information. So now when you're building a data lake, there are some of the common challenges or common issues that may come up. One is, my data spans across multiple sources. How do I get it into a single location? My single location may not grow as my business requirement grows. I have to do analysis on top of that. Now, as my data grows, I need to change the logic of the analytics so that it keeps on performing well when the data also grows. Security, how do I secure my data? So to address all these concerns, we have two options that Microsoft gives on the big data store, which is the data lake and the SQL data warehouse. So in Azure Data Lake, you can pull data from any kind of sources. You store that in the data lake, and then you have all different options to do analytics on top of that. Be it Azure Data Lake Analytics, SD Insight, RScript. You can also run machine learning on top of that. And there is no upper limit on the size of a data lake. There are options where you can subscribe for a pay-as-you-go model, where you keep on saving your files into your data lake account. The storage size increases, and you pay only for the storage size that you are using. So there is no, you don't have to limit yourself, and you keep on trickling your data into the Azure Data Lake. So it grows as the demand grows. So that's the advantage. It is connected to Azure Active Directory. So within your organization, yeah, people use Azure Active Directory to authenticate the users. So that can be used to authenticate users onto Data Lake as well. So it's all within the organization. Right? And then there's a SQL data warehouse, Azure SQL data warehouse. So as I mentioned earlier, this is a massively parallel processing data warehouse. And again over here, the compute and storage are separate. So you may have a small storage requirement, but you need to do a lot of processing on top of that data. So you can have a large compute power, but a small storage. And the compute power can be paused. So if you're not using the compute power, say you did some processing on the database, on the Azure SQL data warehouse, data is ready, you move it to some location, you can pause that data warehouse. So it does not charge you for that. It only charges when the data warehouse is up, running, and the processing is being consumed. So that's how it is architected. And data warehouse can pull data from big data sources. It can have structured data as well as the output of machine learning. So all the data can get stored into the Azure SQL data warehouse, and then you can build reports on top of that. So that's the other usage of data warehouse. So now we spoke about the information management. We saw how do we capture data in an enterprise scenario. Where do we store that? So next would be processing it. What are the tools available to do the processing of such a varied variety of data? Machine learning. So Microsoft has this Azure machine learning offering that makes it very easy to build and deploy different kind of advanced algorithm models and make it available to public. And those are APIs that you call, and it will do the analysis and it will give you the output. And this all becomes available. So this is the snapshot of the ML Studio that can be used to build the logics. So that is one of the options of building advanced algorithms and doing an analysis on top of the data that you have gathered from all the different data sources. Sorry, yeah. The next is the Data Lake Analytics. So this is a service that is built directly right from grounds up for cloud. So again, this also scales depending upon the requirement. So if you need to do a lot of processing, you can allocate huge processing power to that. You are again, the enterprise is charged only for the period that it is being used, and again it scales down automatically. So it can do a lot of data processing, and it supports all these different kind of data sources. It can be data warehouse where you have already done some processing and stored your data. It can be the data lake store where you just trickled in the data from all the different data sources, your social media, line of business application, IoT devices, and now you want to gather or arrive at some intelligence out of that. So that's again a place where you may want to use Azure Data Lake Analytics. So it can go to the data and it can give you intelligence out of that. Obviously, you have to write scripts to derive the intelligence. HD Insight. So HD Insight is a Apache Hadoop distribution on Microsoft. It's 100% compatible with Apache server Hadoop, Apache variant of Hadoop, and because of that, it has all these different options available. So if you are interested in a batch processing of your data, so where data comes in, it rests over there, then you do a batch process of a set of data, then you can use MapReduce. You can write the scripts using Pig or Hive if it's a SQL database. If it's a structured data, you can use Hive. If it's a unstructured data, you can use HBase. And in case if you have streaming data, like data coming from IoT devices, continuously streaming in and you trickling in, and you want to do a continuous processing of the data on an ongoing basis, then Storm is the answer for that. And you want to do an in-memory processing of very large volume where you want very fast processing to be done, then Spark is the answer for that. So within the offering, it has all these options available that can help an enterprise to do a quick insight or to get quick insight from their data. Last is the Stream Analytics. So we spoke about event hubs. So event hub is used to connect to different IoT devices that keeps on sending the data. Once the data comes to the event hub, it can be processed by stream analytics. So event hub is nothing but like a queue. So messages are flowing, and say you have a temperature sensor, right, in a warehouse. So that temperature sensor from the warehouse keeps on sending the temperature information to this event hub. Now this event, then the stream analytics, and it gets queued over here. So event hub does not do much because you want to ensure that it is free to receive that input from the IoT device. IoT devices can send inputs at every 2 or 3 seconds. So if this device or this service starts doing the processing, it's going to take longer. So we want to ensure that this is free. So it receives the information, stores it in a queue. The stream analytics then pulls up that particular information from the queue, the temperature information that the IoT device sent. And then it can be stored in multiple options. It can be either viewed directly on a Power BI dashboard. So you can have a real-time Power BI dashboard which shows the output sent by the IoT device. And you can set alerts over there that, okay, if the temperature from the IoT devices or the temperature devices placed in this particular warehouse increases beyond 25 degrees Celsius or beyond 5 degrees Celsius maybe, you raise an alert. So you know that the products that are placed in that warehouse can withstand up to 8 or 10 degrees. But you want to set an alert at a lower threshold so that you have sufficient time to take corrective action. So this is how it helps you to take corrective actions and address your problems. Earlier, we did not have such flexibilities. You have to manually go and monitor the temperature. But with the IoT devices and all these different services available on cloud, we can quickly do that. And it is very easy to build it. You can store the same information in database, blob storage, or Azure table, or even Azure Data Lake for that matter, to do a processing at a later point of time. So now you got an alert from a dashboard. So you know that, okay, you have to take a corrective action, but you store that information for a future analysis. So when you're doing an analysis in the future, you would know that, okay, this particular warehouse has been giving problems. Is the air conditioning system not working efficiently over there? Should we change that? Is it time to change those systems? So you can derive those insights from that. So we did speak about information management, big data, the analysis of the data. Now comes the intelligence part. So there are different APIs. Many of you would have tried that. There are many APIs available from, again, since I'm talking about the Azure services, again from Microsoft, which are categorized in these different buckets. The first bucket is the vision. So the vision APIs gives the ability to the computer, and it makes it intelligent for computer vision. So what it can do is it can scan images, and it can find out insights from the images. Then there are face recognition. So you can do face recognition. One of the applications of face recognition is, say on again, a retail example, on a cashier till, right? When we go to do our billing in a store, so they usually ask you for your membership ID or for the mobile number so that they can establish a connection between the data and yourself. So now if we have face recognition over there, and if your picture is being stored within the data, it can match your face with that data, and it can tell the cashier that, okay, this person is Ashish. So he does not have to ask you, he knows that you're Ashish, you already registered with the store. So it helps in such scenarios. The other scenario is emotion. So there, it can also understand emotions. So now, again, I'll go back to a retail example itself because it's very easy to understand. We use retail industry almost on a daily basis. So now again, in a superstore or a supermarket, you have cameras fitted at different locations. And these cameras can identify the emotions of, it can send those images of people around there, and the computer can identify the emotion of the people in the store. So it can tell that, okay, this person is not happy. It does not look to be happy in the store. He may not be able to find the things that he wants. So then based on that, you can ask one of your salesperson in the store to go and meet that individual, who can directly go and address his requirement, and he is delighted, right? In today's market, churning customers is a big problem. So it can help you to retain that customer. right? So this is one of the other applications. The other application is video analysis. So again, it can capture videos and it can do the analysis of video. It can tell that, okay, how many different faces are found in the video, what are the emotions of those individuals. It can do those kinds of in-depth analysis. So that was the computer vision. So that gives the ability to your application to do such kind of things. So if you are building an application for an enterprise for retail, you may want to use a face API to detect. For a retail POS application, you want to use face API to detect the person at the POS till. So you know that who the individual is. The other set of APIs are the speech APIs that can do speaker recognition. It can do the language recognition. And then there is again, language, which can do text analytics. Again, that's a very important thing, the text analytics. So we have been using that in our applications where, we gather the post from Facebook, we gather the tweets from the Twitter account, and we do the analysis, the text analysis on top of that. As to what is the sentiment of the user. So it gives the sentiment of the message that has been posted. So whether you're using, the product is bad. I went to the store, but the product was really bad. The customer service was not good. So that tells me that the customer was not happy with my service or my product. So then I can, and if that person has a lot of followers, then it is doing too much of damage for me. It's not just that individual who is impacted or who is going to churn out from me, but he is going to take a lot of people along with him. So the text analytics gives me an opportunity to take a step. Okay, damage is done, I know. He was not happy, he or she was not happy, done, agreed. But now I need to ensure that I need to retain that customer. So the text analytics gives me that opportunity. It can find out the sentiment of those posts, and it can tell you that, okay, this was a bad negative comment against you. So you may want to take, and it can tell you that, okay, there are this many followers. So it's high time you take a action against this. You go and meet with the customer, you interact with the customer, and convert the customer back. So that's where the text, the language analysis comes into picture. Bing search, I know we all use Google. I also use Google. But yeah, there are Bing search APIs which are available that can help you to do different kind of searches. Bots. So yeah. Again, we are used to conversing with bots as well. So anytime you go to a website, you're trying to search something, a pop-up appears on the bottom of the screen that, oh, hi, I'm here. It's usually not a person interacting with you, usually a bot framework or bot that is interacting, and it tries to help us. So it makes the job of a customer support rep much easy. It can do first round of evaluation. It might be able to address the customer's concern, and at the end, you're going to have a happy customer. So all this is to ensure that you have delighted customers at the end of the day. Yeah. Cortana. So I don't know how many of you use Windows 10 desktops or laptops, but it comes with Cortana Assistant. Windows mobile phone, I think it's out of, it is no longer available. But yeah, Windows devices come pre-installed with Cortana Assistant. So in Cortana, you can type in questions and it can give answers to that. And for an enterprise scenario, it can get connected with Power BI, which is a dashboard tool. It's not just a dashboard tool. It would be too bad to call it just as a dashboard tool. It's a BI tool on its own, where it can gather the data, do transformation, and can publish the reports, interactive reports using Power BI. So Cortana can also get connected with Power BI, and you can type the question, okay, what is my sales for today? And it can show you the data from your Power BI connected report and within the Cortana itself. So it's that intelligent, and it's connected. So that's how it helps enterprises. Or earlier, when there was a Cortana, when there was mobile Windows Mobile also, we would be able to show an example of, you can even talk to the Cortana. It recognizes voice, so you can say, okay, what is my sales? And a chart will pop up on your mobile device. So which is very handy for people who are always on the move. Right? So now, yeah, the last part. So we've discussed about all this, and the last section is the dashboard and the visualization section. So that's where Power BI plays its role. So we spoke about all these different interfaces, the stream analytics, event hub, machine learning, the blob storage or Azure Data Lake, the data warehouse, HD Insight. Power BI can talk to all these different data sources. And it's not limited to only Microsoft data sources. It can connect to any on-premise data source. It can connect to cloud-based data sources. It can directly connect to cloud-based software as a service providers like SaaS or Salesforce. And it can pull the information from there and build interactive dashboards. So that's where Power BI comes in play. So this is the complete landscape that we saw earlier. And this is how each of them play a role in an enterprise data visualization and insight. So yeah, this is what I wanted to show, and I have a video. I would like to play a video about how Cortana and the Microsoft BI tools have helped in ensuring that the patients get proper assistance when needed. I'll have to.
The U.S. healthcare system is challenged by the task to deliver exceptional, personalized care at a lower cost. Despite spending nearly 1/5 of our gross domestic product on healthcare, we struggle to meet this goal. Financial pressures on care providers are increasing. This isn't sustainable. So how can we deliver high-quality, personalized care that patients deserve, given the cost pressures we face? At Dartmouth-Hitchcock, we've created Imagine Care, a new cloud-based solution built on Cortana Intelligence and Dynamics CRM that enables providers to help patients achieve better health. With the help of Microsoft, Dartmouth-Hitchcock is building a technology platform to serve healthcare organizations and patients across the country, setting a new standard for personalized care. Now, using machine intelligence, providers can develop a care plan that's unique to each patient. We can monitor patients from their homes, where data is collected from devices and sent to the cloud, to Imagine Care's 24/7 contact center, where registered nurses continually monitor a patient's health status and potentially serious trends.
Cortana, summarize health status for Ben Andrews. Ben Andrews' weight has increased more than 2 pounds in the last 24 hours. Please review the home diuresis protocol prescribed by Dr. Phillips.
Patients get reminders and encouragement and dynamic updates to their care plans, improving their health, helping them avoid unnecessary trips to the emergency room, and reducing the cost of care. With support from loved ones and real-time interventions, there is less likelihood of readmission. With Cortana Intelligence and Dynamics, we're transforming the way healthcare is delivered today, improving patient outcomes, reducing costs, and offering an unprecedented level of personalized care.
This is one of the examples of where the complete stack that we just discussed helps in achieving the enterprise goals. So I'm here to take questions.
So where is the border? Is there any border or something like between normal data and big data, or when we code something in big data?
Anything that meets the 3 basic requirements. So there's variety of data. So you have different kind of data. Velocity. So it's coming fast, right? Maybe hundreds and thousands of pings every second. And there is volume. It's huge. Huge means it cannot, so see for anything that is moving fast, right, you will need systems or you need application that can ingest that quickly, which cannot be done by a normal or regular system. So that's where you would need a big data system. So if you have your basic line of business application where you are generating bills or anything, so that does not get qualified as big data. But when that comes and merges with other factors, like your IoT devices, your warehouse information, your manufacturing plant information, all that put together will form big data for you.
Okay. I have a basic question. Why did you opt for Microsoft Azure not other platforms for business reasons or?
My comfort zone. No, I've been working with Microsoft all this while. So Microsoft is in my blood. I can say that. So that's where I chose Microsoft. Yeah. I'm a Microsoft certified professional since '97, where I wrote my first test on Microsoft, and then I wrote test on SQL also. So I'm very well versed with Microsoft's stack of tools and technology.
Any other questions? So then let's thank the speaker.
Okay. Thanks to you all also to be patient and you listen to me. Thanks a lot.